Hi guys, good day. It's me, Teacher MJ. Our topic for today is all about the side angle side or SAS congruence postulate. So without further ado, let's do this topic. So once again class, later on we do have some examples to check if the two triangles are congruent or not. So once again, in SAS postulate, once we prove that it is an SAS congruence postulate, any parts of the two triangles are congruent. Alright? So once we prove that it is SAS or the two triangles are congruent, side angle side, any parts of the triangle class are congruent. So according to the SAS theorem, two sides and the included angle of one triangle are congruent to the other two sides and the included angle of another triangle. So what do you mean by that, sir? So example, if we have a triangle, okay, we have a triangle and we have this side and this side, okay, this side and this side. So where should be the included angle? So you will be asking, sir, where is the included angle? So note, do not forget the note. Note, the included angle is any angle between, okay, between the two sides. So what is that, sir? Between the two sides, meaning it is on the middle part. So between the two sides. So this is the side, first side and the other side. So which would, where would be the angle class? Is this the angle will be here? Okay, or not? Of course not. So between, if these are the two sides, so angle must be here. Okay, the angle must be between the two sides. So if the angle is not between the two sides, okay, the angle is not between the two sides, so that is not an SAS, because SAS, side angle must be between the two sides. Okay, between the two sides. So let's check. Let's have an example for you to really understand this one with a given example that we have. So we have two triangles. We need to prove if it's congruent or not. So we have a given A. So we do have a markings. Do not forget class, we have a markings. If there's a markings, that would be easy for you to check if it's side angle side or SAS or side ASA or AA postulate. So we do have many postulates. We have 4. So AB and DE. So let's check. So we can say, since we do have a markings, okay, markings, we can say that AB, this line AB is congruent, okay, congruent to line DE. Check the angle class. Is the angle between these two sides? Yes, the angle is between the two sides. So we can mark this one up. So let's label this one. So we can say that this angle D, okay, angle D or angle A, start with A, angle A is congruent to angle D. Right, angle A is congruent to angle D. What else, class? As you can see with a given example, yes, this is AC is congruent to DF. Same markings, okay, same markings. So we have angle, line AC, okay, line AC is congruent to line DF. So this is side, so AB, DE, so side 1, we have side, and then angle, the angle A and angle D, we have an angle, and we have a side, okay, side angle side or side angle side. So therefore we can say that since we proved that these three parts, okay, this first side, the second angle and the second side are congruent, so therefore we can say that triangle, okay, we can write this as triangle, okay, ABC is congruent to, so if you need to, do not forget class, if you read this one as ABC, okay, you also read that DEF, congruent triangle DEF. So therefore these two triangles are congruent. You can also read that triangle BAC, triangle BAC is congruent to triangle EDF. EDF. It's actually the same class. Okay, so therefore, we know that these two triangles are congruent. That's according to SAS, side angle side. So that's it, class. That's how you deal with side angle side. Okay, so let's have two examples to check if the two triangles are congruent. So let's have example number 1. So give an example, you check. Okay, if the teacher will ask you to tell if the two triangles are congruent or not. So let's have example number 1. So given with the markings, so we have, okay, the angle is the included of these two sides. Check, class. Check the angle if it's included of these two sides. Of course, the angle form with a box, this means that this angle is 90 degrees angle. Okay, given 90 degrees angle. So what will be the equals, class? Is MP equivalent to QS? Check if is it MP equivalent to QS with regards to the markings? Of course not. Okay, of course not. MP, there's only one mark, and QS, two markings. So therefore, we can say that MP is congruent to SR. Okay, MP is congruent to RS or SR. That would be okay. So MP, line MP is congruent to line. You can write it SR, MP, RS or SR. That's okay. So let's just put RS. MP is congruent to RS. So we have side. So this is our side. And what else, class? MP, RS, and we have an angle. Of course, this angle is congruent to this angle. Same measure, 90 degrees. So this is congruent to this side, this angle. So we can say that angle P is congruent to angle S. So we have an angle. Last one. So angle or line NP. Okay. Line NP is congruent to what would be the congruent of NP? NP, so check the markings. So the congruent it would be QS. Side QS. Alright, so we have side angle side. So therefore, once we prove that the side angle side of the two triangles are congruent, so therefore any parts of these two triangles are congruent. Okay, any parts, class, of these two triangles are congruent. Alright, so we can say that triangle, okay, triangle MPN, so we have MPN is congruent to, so you start at MPN, do not forget MPN with the first marking, you start with the first marking, MPN, so it should be RSQ. Okay, you start at the first marking, RSQ. MPN, it should be triangle RSQ. Okay, MPN RSQ. So check the marking, class, with regards to two triangles. Do not forget, once you read it MPN, the other side it should be RSQ with regards to the marking. So you have one line here, one line, so you need to read it as RSQ, MPN. You read it MPN, it should be RSQ. It should not be QSR, because Q, you start at two lines, two markings, so it should be MPN RSQ. It should be symmetrical, class. Okay, that's how you read the triangles. So congruent or not, therefore this is congruent. We already proved it by SAS postulate. Alright, let's try another example. So what if we have a tricky example? What if we have right here, give an example, you check if it's congruent or not. So we only have, okay, we only have two markings here. So you need to check if it's congruent or not. So given, so we have given this side is congruent to this side. So we can say that AB, okay, AB, AC is congruent to EC. So AC, it should be EC. But it's actually the same class, CE or EC, but you just read it symmetrical to the other side. AC, it should be EC. Alright, AC is congruent to EC. So what else? So we have side. So what is class? We can say that DC, okay, or BC. So let's write it BC. Line BC is congruent to line DC. So BC, you read it DC. DC. And we have another side. Okay. So we now have two sides. So what is class? What else can you see here? Is there anything that you can see? You can check if we can give with regards to angle. Can we prove that this is congruent or not with regards to SAS? Because our topic is SAS, side, angle, side. Yes, that's correct. With regards to this angle, okay, this angle, it should be congruent. Check the included side, included angles, included angle class. If these are the two sides, the included angle must be on this, in this angle. Why is that, sir? Because according to SAS, the included angle must be between the two sides. So this will be the included angle. But we need to know if these included angles are congruent. Is it congruent? Yes, that's correct. It is congruent according to vertical angles. So do you still remember, class, the vertical angles? Vertical angles. So vertical angles are formed by two intersecting lines. So if we have two lines intersecting to each other, two lines intersecting to each other, therefore those vertical angles are congruent. So where are the vertical angles? So if we have two lines intersecting or intersect to each other, two lines intersect to each other, okay, two lines intersecting to each other, we form vertical angles. So this angle right here is congruent to this angle, and this angle right here is congruent to this angle. So those are vertical angle class. Without the markings, okay, without the markings, you need to know if the two triangles are congruent or not. So without the marking class, you already know that these two angles are congruent because of vertical angles. It should be mandatory, class, that those vertical angles are congruent. So let's have another example. So what if we have an intersecting line like this? So what would be the vertical angles formed? That's correct. So this angle here and this angle, it should be congruent. And this angle formed right here and this angle, it should be congruent. That's according to vertical angles. Vertical angles are congruent. So therefore, so we have two sides now. We have side, this side and this side are congruent. This side and this side are congruent. So, and we already know that this angle is congruent to this angle. So we can say that angle ACB, okay, let me write it in blue. So angle ACB is congruent to angle, so you read it ACB, you start with two markings, ACB, so the other side it should be ECD, angle ECD. So this is angle. Okay, so we have side, and angle, but we need to check, as we all know, that the angle is in between the two sides. Angle is in between the two sides, so therefore this is side, angle, side. SAS, because the angle is between the two sides. Side, angle, side. So we have side, angle, side, because the angle is between the two sides. Side, angle, side. Alright, so we have side, angle, side. Side, angle, side. So therefore, we can say, since we prove it by SAS, side, angle, side, so we can say that the two triangles are congruent. SAS. So we can write it triangle ACB is congruent to triangle ECD. triangle ECD. And these two triangles are congruent. We prove it by SAS. Alright, so these two triangles are congruent. So that's how you deal, class, with SAS with regards to the two triangles. So just check the markings. Check the markings. You label that one. So you label the markings. So you do it symmetrically. It should be symmetrical. So AC, it should be EC. But that's actually it with regards to the same with regards to the measure, class. That's actually the same. So AC, same measurement with EC, or you can say it's CE, but we just write it symmetrically. So it would be the same with this. We read it AC, so we do it EC. But with regards to the measure, that would be the same. So we prove it that those sides, angle sides, the other side, the other part, side, angle, side, are congruent. So therefore, these two triangles are congruent. So with regards to answering the postulate, class, you just need to be careful with the markings. Alright? Be careful with the markings. I hope this video helps. If you like this video, do not forget to subscribe, class. You share to your friends and to your classmates so that we can help them. Once again, this is Teacher MJ, and goodbye for now. Bye-bye.